of Erectors from 1998-2004, and again during the current term, 2016-18. He's been active in that association since 1995. He's the president of Dean Structural Services LLC in Longview, Texas, and they're an AIC Advanced Certified Steel Erector, and was founded in 2013. David has more than 30 years experience in the steel erection industry and is a strong advocate for the advancement of industry quality and safety standards via education and personnel and the promotion of organizations such as SIA, AIC, and NISD. He's assisted today by Kobe Tribble, who's the estimating manager for Dean Structural Services. Kobe has worked for a fabricator for 12 years and worked for Dean for 5 years. He's been in contract administration and was educated at TSTC and was a former Z-Tech. So we'll get started with David Dean, Kobe Tribble.
Well, thanks for everybody for coming. As you know, I'm a steel erector. Don't hold that against me yet. And I'm really happy to do this because I am a very strong advocate and fan of the NISD, number one, and the Steel Erectors Association. We are specialty contractors. That's what we sell. And if we do it right with the communication between the parties, and of course the dark side of the fabricators, you know, we can provide a pretty good product, and it's safe and efficient, and everybody goes home with a little profit and happy. So we hope what we want to do, goals. We have some learning objectives today. We want you to understand what we have to go through in erection planning, including crane size, placement, sequencing, etc. Everybody talks about it. Hopefully we have some slides here and some examples that make you better understand why it is important. We hope that you get a little bit more cognizant of erector-friendly connections and subpart R requirements. Everybody here, I'm assuming, knows who OSHA is, right? And you hopefully know what subpart R is, which is the steel erection standard of OSHA. And back about 2000, when the subpart R got rewrote, I was privileged enough to work through SIA and NISD to come up with a little detailing for erection safety and efficiency standard. It is still available today. Go to the SIA website and you can purchase one if you haven't ever heard of it. And a lot of this stuff in here, I'm going to give them kudos, comes from that, as well as some other fabricators that were kind enough to help me. I can't believe my phone is ringing. Yeah, so that's what and then better understand how to provide information on field use drawings, obviously. You know, that's the deal. So we know the keys for success. There are many key players: owners, architects, engineers, general contractors, fabricators, detailers, erectors. Often two of the last brought to the table is the detailer and the erector, even though we may play one of the most important roles to the success of the project. Okay? Detailers obviously are the first ones to take a really good look at the plans. You're expected to have 0 defects. We expect every little piece to be exactly detailed correctly and fit just right. And you have to, many times nowadays, obviously you have connection design responsibilities as well. So you directly control the sequence and the duration of the steel delivery via your drawing submittals and how you get them to the fabricator. And like I said, you're also probably nowadays, at least where we are from in Texas, there's a lot of connection design responsibility that's now being delegated to the fabricator, which they're obviously delegating to you. So that's bad in a way, but it's good in a way for the erector, because if we can communicate and get the kind of connections that are, you know, safe and more efficient, I'd much rather have a detailer designing connections that we can agree on than me having to do exactly what the EOR shows on a set of plans, because they are not the specialty contractor. Okay? Us poor erectors, you know the saying, you know what rolls downhill, right? And we're the last guys there. And so we're the ones that are responsible for making it all fit, come together, safely, plumb, and get it up without regard to weather, site conditions, completed on time, on schedule, safe, consistent with industry standards and OSHA requirements. So, you know, obviously it's pretty important to us what that product, how it comes, what it looks like when it gets there, and how it either bolts or welds. So, I'll go back to that little crane slide. Just a minute. Yeah, this really has not a whole lot to do with detailed connections exactly, right? But it's just to show you, this is interesting, this is what erectors put up with sometimes. This is a pedestrian bridge that went across a college main thoroughfare. And so we had to, you know, build it on the side of the road, get all the permits, get everything ready, get that 500-ton crane built, and then we're gonna make this pick on Saturday morning, and by God, we better be out of there by Sunday at 5 p.m. And what happens on Saturday morning? That, snow. So, anyway, it's just kind of and we did manage to get it up and get out of there, but that's kind of the kind of stuff we have to put up with. And, you know, the university, they may have been nice and said, well, we understand, Dave, it's snow, but probably not. So, you know, we have a lot of things in common. You know, a successful project, quality product, accident-free, efficient and productive for everybody, which means probably profitable for everybody. And, you know, a profitable erector is a happy erector, right? And we have a lot of obstacles that are the same, such as the AE team and incomplete drawings, ambiguous specifications and catch-all phrases. We've all been there. The general contractor and construction manager who doesn't really always coordinate with other trades. You know, you're looking for HVAC information and they're not getting it to you because maybe they bought it, maybe they haven't, maybe they just decide they're going to forward the emails back and forth and they don't really get involved. We all have personnel problems these days, recruiting employees and retaining them in this market right now. And then we also have that dark side called the fabricator. All right? And so a lot of times, you know, maybe they wait a little bit later before they decide what erector they're going to use. And so they've already turned you loose detailing, and they told you to start on building A, and we really need to start on building C, and it's too late now because you've controlled the drawings, like I said, so that's what they're getting first is building A. And not all of them, but some, you know, there are project managers that they're gonna get a question from a detailer, and then they're just gonna carbon copy or forward it via email. They don't really pay a whole lot of attention to it because they don't think it's their problem. So there was a time once when I went to the dark side and I worked for a fabricator as a project manager. And back then, it shows you how old I am, I guess, when I say back then, right? But fabricators did a lot of in-house detailing. So it was real easy for me to just get up off my desk, walk down the hall, find my detailing manager, and talk about sequencing and connections and stuff. Well, you know, those days, like I said, are not totally gone, but a lot gone. And so communication becomes a real problem. And that's the whole point of this kind of seminar today. And that's what I really respect about the NISD, because they allow us to communicate. So first thing we like to do as erectors, obviously, is plan the erection sequence, and we like to get the detailer involved. Now, the part on the left there is basically our in-house job startup procedures, basically saying who needs to attend and what we're gonna do at that meeting, which is basically go over the site-specific erection plan and the safety plan. And so we love to have the detailers involved when possible. But in case we're not involved, there's some things that you could ask your fabricator when he turns you loose with the deal, okay? And that would be sequence, schedule, some kind of shipping requirements. Is there you're gonna detail something that's 100 foot long, but unfortunately the site won't allow a 100 foot long girder to get delivered over there. So if that's the case, then what kind of splices are we wanting? A lot of times the splices and whether the 100 foot long girder is also might be determined by the crane capacity that we have to use on the site. So, you could ask that question. There's obviously splice connections, where they're at, their locations, bolted versus welding, value engineering, edge angle, shop welded versus field welded, those kind of things. So those are things that if we're invited to the party, we'll be glad to discuss, but unfortunately, sometimes we don't get invited to the party when you're getting turned loose. This is a good picture of why sequencing and delivery is important. You see that crane in an alleyway there, and we basically built this truss up on the roof in advance with a contractor-provided tower crane. Obviously, the tower crane didn't have the capacity to build the truss or set the truss on, so we have to bring this 550-ton hydro crane in there to set it. Well, you can see that if we were missing a piece or something, that crane wasn't gonna swing around and go get it, right? So that was a very, tight, I don't wanna say well thought of, but, it took a lot of coordination from the construction manager, the fabricator, and the erector, and our erection crane crew, because we basically pulled that crane in there on a Friday afternoon at 4 o'clock and had it out of there by Monday morning at 6 a.m. But that was a main thoroughfare for delivery for the hospital. This right here is just another little project we did, and it kind of shows you right in there. This is our crane plot layouts, and these are some critical lifts and the sequences. Now, obviously, if this thing right here was not there on time, we certainly couldn't build any of this because that's where the crane had to be, and there was just, this is a tight downtown Dallas, Texas job site. So again, delivery of material, when it got there, it had to be there on the right time. And what you don't see, there was also the Dallas Rapid Area Transit train ran alongside where that job site fence is. And so it was a rather tight little thing that went really well. I'll give Bays and Steel some credit. No, excuse me, that wasn't you, I'm sorry. Anyway, we're gonna talk about putting stuff on hold later in the sequencing, and that's just kind of shows you the type of building and why. Some people sometimes don't understand why is David so upset over this missing W16 by 26. Well, that's why, right? And this is just another part of the site-specific erection plan showing the critical lift checks that we do. And you see some of the waste here on some of these trusses. So, we were talking about splice locations and delivery. All this stuff had to get delivered on time and erected when we had the crane in the right spot, or it wasn't going to get erected. So tight restraints are very common. And this is a picture of the actual job site. Probably about 1/3 of the way through. And you see the crane there in the middle and how we're basically building it in a horseshoe. So we want to talk about erection-friendly connections. Not only when I say erection-friendly, I mean safe, easy to do, and as per OSHA requirements. And one of the big things is column splices, as you know. So if you look at that job right there, you see how high up that column splice is? So you can imagine the connector is gonna have to get a ladder or something up there just to make that column splice and then weld it. So that's not an ideal erection friendly location. And so be cognizant of OSHA requirements and understand, you know, that we gotta access this stuff. Yeah, and that's just showing some of the. Alright.
6 foot above your head.
Quick question, what's that kind of erection aid called?
Glad hand is one of the things we call it.
Well, that's one I hadn't heard before, I've heard several, but not.
That's what we call it, glad hands, but obviously, you know, the idea is, and again, that connection has to support the column above it and a 300-pound force at the top of the column, right? So it's a temporary aid that the design engineer is not gonna, he's not gonna tell us how to do it. So communication is the key. Obviously, you want to verify with us, hopefully, where the field light splices will be. And in the best locations, typically it's 4 feet above the top of steel. And we like to, myself, Dean, likes to have column splices at even levels. In other words, if it's a 4-story building, we want the column splice 4 feet above level 3, right? We got a 2nd floor, 3rd floor, then we want the column splice 4 feet above that. And it works that way all the way up. Occasionally, you know, 3-story building, you might get a single shaft column. The problem with that is when you have a column that is, say this column right here is 3 floors, 50 feet tall. Well, we hang this column, this beam right here, and we can't do anything with it except connect it and put our connection bolts in there, but we still gotta get these 2 beams right here in, and if you go tightening that up all the way, you're probably not gonna get these 2 beams in, so that's why we like to do 2 floors at a time, you know, all the way as it goes, so 2 floors, 2 floors, 2 floors, 2 floors. And we were talking about OSHA requirements, and this is one of my biggest pet peeves. You cannot believe that this requirement about double connections of columns has been in force for 19 years now. All right, and we still get steel delivered to a job site occasionally with double connections in the web. Now, this little red deal right here came out of a job spec. So this engineer, obviously, to me, either was involved in some double connection that some erector lost, or, you know, I mean, because he made it a point to really put that in red, and I've never seen that before, and so I just included it in this deal because it's like this guy probably had a problem. Okay, now this is what happens for an erector. You send the fabricator sends a column out there with those kind of double connections that are illegal per OSHA, basically, all right? Now, what am I gonna do? I'm gonna call them up and say, man, you know, we can't be doing this. Well, it's too late. So I have to do one of 2 things. I either have to erect the building as is and hope I got some really good connectors out there that understand how to make double connections, or I gotta do something in the field weld a seat or something on there, or temporarily weld a connection tab, you know, replace the bolts, weld a couple inches of weld, pull the bolts out so that I can make sure we don't have that condition. All right, well, what's gonna happen 9 times out of 10 when you got a crane and all your folks on site and a schedule to keep? You're probably going to go the first route and make sure we got talented connectors up there. Okay, so now if something was to happen, OSHA says, go to the next page, OSHA says, I'm not supposed to be doing that. So if there was a problem you know, I am like, well, I might be going to jail, right? Because I just let this guy do something that is absolutely positively not per OSHA subpart R standards. Now, design engineers aren't gonna show you that 9 times out of 10. You know, they're worried about connection design, when the finished product. Our job is to get it up there and erect it and get it to that point where it's finished. And that's why it's so important for detailers to understand that. We talked about perimeter columns, we want them 48 inches for 2 reasons. Number one, it's a accessible deal. The other is, we have to put perimeter cable around these columns, right? Y'all probably know that by now. I don't know if you knew it or not though, but it says they shall not be erected. Now, if you know anything about the AISC, OSHA's the same way. When you hear the word shall not, that is not, well, maybe you shouldn't, or, you know, it might be a good idea. That means you shall not. So if you send me fabricator sends me a column out there that is a perimeter column that doesn't have some kind of holes or tabs, there's a pipe column, something to run that cable through, OSHA says I'm not even supposed to stay in that column until I do something about it. So, sometimes, you know, people think that erectors are just asking for stuff because it's gonna make it easier on us and we're gonna, you know, we wanna make money, but sometimes it's actually there's, you know, we don't wanna break rules. The next one talks about double connections, and there's the OSHA language that came right out of subpart R750, all right? So, we're gonna show a couple examples of what we like. That is actually in the OSHA, that came from the OSHA subpart R, that's not a detailing standard from anybody or whatever, but OSHA cared enough about it to give an example, okay? So, it's kind of important. So, these are some examples of what we like to see. The one on the left over here, this is what I call the erector-friendly column, okay? And it's erector-friendly for a lot of reasons. It's got 4 bolts for anchor bolts. It's got some double connection aids. It's got perimeter cable holes. And it's got a stabilizer for the joist and the joist seat. And it's got some deck angle supports for when the deck goes around the column, if that's an H column. And this one on the right, these are some of Bays and Steel's standards to accomplish this double connection problem that we all need to be, like I said, I'm astounded that it's 19 years and we're still dealing with this sometimes. All right? I will say this too, if you do a seat like that, if there should be a little note up here, if that beam and that beam are the same, gonna have the same hole pattern, and you're only gonna put a seat on one side, you need to tell the erector on the drawings which side, how he needs to start the building. How would you know that? If you went, because of the sequence. Myself, I prefer just put it on both of them. It doesn't cost that much more money. You've already punched this hole here, so just give you another angle, and then we don't have to worry about it. We have to switch back and forth. There's some other details. We like to have erection holes in the top of columns for a shackle or a pull pin. So, you know, again, ask the question. A lot of fabricators have standards, what they want to use. You just ask the question what they would like. And that's right there is a double connection in a web of a beam. And most erectors will tell you that while this condition is okay, we live with it, any erector will probably tell you we'd rather have shear tabs in lieu of that, right? There it is. Now, any fabricator, a lot of fabricators are gonna tell you, we don't wanna do shear tabs, we gotta weld that, we're gonna run this stuff through the beam line, okay? And I get that, we're all in it to make money, so here's a really good solution that Basin came up with that is, if the loads will allow, it's a shear tab connection, basically, that's a bolted angle clip, so he can still run it through his beam line. They put those angles on in the shop, it comes to me and it's basically a shear tab. But it keeps the fabricator from having to do the welding. I'm sure most of you, if you detail bracing, know we need an erection aid. A lot of times design engineers actually put it in there. Most of the time they don't, because they don't really care. That's the most common one right there, one hole in a HSS member. And that's okay, but the even more preferred one is the next one, where we actually have some multi-holes here, right? So because what we're gonna have to do is we're gonna have to put a spud wrench in this hole and then stick a bolt in there, right? So if you only got one hole to line it with, it can be done, but it's a heck of a lot easier to have one hole for lining up and one hole to put the bolt in.
Sorry, I didn't hear that. The other one's the favorite connection for the bolted bracing. If you could do that, it eliminates the weld for the bracing and saves everybody time, money, and a headache.
Exactly.
That's what,
This one is angle right there. That's an angle kicker, obviously, going from a joist to a beam. Now, we understand joists are coming from a different source than the fabricator. All right, but rather than this little fancy little drawing right here, which means I have to cut all that in the field and make it just right, put a little shear tab right there. I'll put that on in the field, I understand that, but that's a lot easier than trying to make that cobalt nice and pretty and make it all look real good. And right here, if you just put a stiffener or some kind of tab right there, then that angle right there can be square cut, as can that. These over here are, I alluded to earlier, deck support around columns, so we've all probably seen some of this, right? Well, you know, there's a detailer that'll say, well, just send that 3x3 angle out there and field cut all that stuff. Well, the truth of the matter is, no matter what these beam sizes are, you can come up with an angle that's it'll fit just about 99.9% of the situations on that building, and it could be the same piece mark and we'll make it work. But I'm not field cutting it in the field. In this case, this is a header beam going to another header beam, all right? And there's probably a transfer column up on top. So these beams have to have stiffeners in them, right? So what do you think the problem is here?
Trap beam.
You got stiffeners on both sides on both beams. So, you know, the beam is not gonna go in there. So at this point, there's two choices. Cut that out in the field, which means I'm cutting that on the field. If you all know this, you've all read this little note on the structural notes drawings. Do not fire up a torch, by God, unless the engineer record says you can. So when I cut that gusset off, now I gotta grind all that weld, I gotta make that look pretty, and then put a new gusset in, because the old one's not gonna really work, and because it's not gonna be wide enough, no matter what you do. So if you get with the erector ahead of time, as me, I'd much rather just feel weld one of those plates in, knowing in ahead of time that's what we gotta do, versus cutting it off and then turn right around and field weld. And now we get to the wonderful field welding and that lovely symbol that all erectors love right here. Weld all around. Right? I mean, it doesn't matter what it is. I'm not gonna worry about it. By God, we just weld it all the way around and I'm taking care of it. Well, sometimes you can't even weld it all the way around. Right? And we know that we probably don't need to have it welded all the way around. But this is where we need you guys through the RFI process to ask the question. We get into staggered welds on bent plate and elevator sill angles and stuff. You know, we like to try to get away with overhead welding whenever possible. I'd rather do stitch welds 2-on-6 or 3-on-6 than have a staggered 3-on-12 flat and overhead. on to the next one. And this is a really interesting case right here. It's one of my favorites. Now, hopefully I can talk loud enough so you can hear me. So what happened here is, this is a bid document, and the poor erector said, oh, good, that's a good idea, I'll just bolt that. And that's how we put it in our bid. And yeah, we might want some kind of slots in here for adjustment for this. Okay, well then, lo and behold, during the approval process, or while the detailer was drawing it, the engineer record changed the loads on this thing. This is a balcony support, right? And so the detailer goes, oh my God, the 4 bolts aren't gonna get it. We're gonna have to weld it. Well, the problem with that is, number one, he didn't tell anybody he's gonna do that. He just did it. So now I've lost my opportunity to go with the owner and say, look, Mr. Owner, do you really need them loads increased? Because this field welding over here is a heck of a lot more expensive than putting them 4 bolts in. Then, to make it even more fun, they decided to weld it, and they put a full pin weld right here. So what do you think the cost difference is between that and welding, and then that and a full pin weld? And I'm looking at it and I'm going, well, wait a minute, you got a fillet weld right here. Why the heck do I need a full pin weld this over here? And what was the answer? Yeah, Daisy might be right. We were. But again, it's communication, right? So we can get things changed proactively, asking a question during the approval process. If the owner realized, well, wait a minute, it's gonna cost me some extra money, maybe he'll decide he can live with it. Or maybe the owner will put a pressure on the design team. You know, really? This is another one where, you know, this is a chef load to support CMU. All right, it came out from the detailer, continuous weld. So this piece is 10 foot long, and I'm supposed to put a continuous weld all the way across right here. But in other areas, he had this drawn up for the occasions that this was put on in the shop. So I call him up and go, well, if it's good enough for the fabricator, why isn't it good enough for me? Again, it's, well, Dave, you're probably right. So just to let you know, here's the cost analysis of putting a 10 foot, say this piece is 10 foot, and I'm gonna put 3-inch welds on 3 on 12. It's gonna take me about a half a man hour to weld that. Cost of the seam weld, about 6 man hours plus or minus, okay? So at, say about $115 a man, which would be the man, the boom lift, the weld machine, you go from $57.50 to $690 just for this one piece. And then, when you think about there was 25 of these, I don't have to tell you the math. Again, this is the same thing, you know, right here, we all see this. Well, you know, ask the question. That's probably, I would put really good money that could probably be a stitch weld if somebody asked the question. And this right here is, Mr. Simonson can help me with this. I'm sure this is a seismic connection with this language right here. All right. Well, sometimes design engineers are they design seismic stuff so much that they put typical details in there, and we might not be in a seismic zone. So maybe I do not have to take that backing bar off, and maybe I do not have to back gouge it, and maybe if he wants me to back gouge it and weld it here, maybe I don't even need the backing bar. And then one of the biggest problems we have in the field, and we understand detailers, okay? We understand your problems. But you take this opening right here. This was probably a elevator mechanic, either an elevator opening or more than likely a mechanical chase, okay? So. You can get a slide. So the detailer is asking the general contractor over and over again, what's this dimension? What's this dimension? What's this dimension? It's not getting answered. So he puts this beam on hold right here to protect himself, right? I can't locate these, so I'm gonna put all this on hold right here. All right? So we got a couple of W10 by 12s that probably weigh less than 100 pounds, say. If it's 10 foot, it's 120 pounds, right? And we're holding this girder up for that. Well, now I can't hang this. If my erection sequence is going in this flow, I'm not gonna hang this because that'd be a double connection, that'd be a no-no. I can't hang this, and if my crane is, if we're on a situation like that slide we showed you earlier, where everything has to be done in sequence, I might not be able to hang this, all right? So what happens is, my erection foreman calls up the fabricator and goes, hey, I'm missing this W24 by 55 right here. Where is it? Project manager, I don't know, let me check. Calls up his detailer. Oh, well, don't you remember I put that thing on hold? I ain't got my RFI answered yet. So now I'm sitting out there with a crane and a crew and boom lifts. And I can't hang any of this building because of these two little W10s, right? Now here's the deal. If we are proactive, Dean might get paid to put these two W10 by 12s in because we're gonna keep the schedule going, Mr. Contractor, and we're gonna tell you up front, well, this is gonna cost you $750 to put this in, all right? Now I'm telling them up front, we got a problem, but this is the solution we got for you. We'll put these in, field weld or mag drill the connections, whatever, when you get your act together. In the meantime, we can still build this whole building. They'll probably pay me for that. And they might even pat me on the back and say, man, we really appreciate what a proactive guy you are. Here's what they're not gonna pay me for. Because I can get paid for work that I did. And anybody in this room will tell you it's hard as heck to get paid for work you didn't do, right? This is delay time, okay? So I'm gonna go into a contractor and say, man, I lost $5,080 today because you couldn't get your act together. You think he's gonna pay me for that? No, I'm a crybaby, right? Oh, David, quit bitching, right? The truth of the matter is, I could have been the hero, and you could have been the hero, we've all been the hero, the doctor kept on listening, right? So, and nowadays, with the great software that we have and the way people can track beams from the time it's drawn to the time it goes out the shop to the time it gets to the job, there's really no reason for people not to be aware of this, right? So if you're doing a job and this is in a sequence number 15, and you know the fabricator's only delivered sequence 3 so far, yeah, you might have a little time and we might can work with the fabricator, you might get the answers and say, hey, this is gonna be a problem 3 weeks from now. But the problem is when it becomes a problem the day that this beam is supposed to show up. And this is an interesting little picture that I thought that was pretty cool for legibility of field use plan, right? Here I am over here going, there's 4 of these. Here you are going, no, dummy, there's 3. So when we talk about legibility of plans and how we want details done, you have to keep in mind that this is what we're working on right here, right? This is a nice, pretty day. This is ideal conditions. Wonder if it's a little misty rain, a little overcast, can't really see the drawings all that good. So you may think it's clear as can be, on your PC in the office, but it might not be so clear when you're dealing with this paper out in the field. So just be cognizant of this is how we build the building right here, right? Now, we are kind of proactive and we use iPads for like shop drawings and stuff, and you know, everybody's getting in a digital age, but I can tell you, the old-fashioned raising gang foreman is gonna use drawings. So, and it's probably not gonna change as far as the actual erection drawings of putting piece number B120 up where it belongs. We like to have paper. Now, detailed drawings and stuff like that, you know, we're gonna put it on the iPad, and they're pretty handy. So, ask the questions again in the pre-planning, if there's splices that are shown. So typical, this is a beam, right, it's going across the top of the column, and we got a splice here, all right? We need to show that pretty good on the erection plans, because you gotta realize, my raising gang foreman, when he gets those field use drawings, that's what he's looking at. He's not looking, he's gotta put this piece in the right place, and he's just looking at this piece number. And it's really helpful to know where these splices are in cases like this. So if they're shown up on the drawing really clear, you know, I mean, that's what we're asking for. And another thing is, there's no such thing as too many details, right?
The better, more sections, the better.
Yeah, really, the more sections, the better, to make everything clear. And obviously, we like to see section cuts on another sheet, not over in a corner somewhere, buried somehow or another. Right? And reference them really nice, you know, really tell me where I can find that detail. Now, this is an example of putting too much information on a drawing. If you look at that right there, that's gonna be pretty hard for me to digest all that, particularly in the field, on a dark afternoon or whatever. So get rid of the stuff that you're trying to portray here, or use two sheets or whatever, and make this to where we can actually read it, and read the piece marks and tell what's going on here. And this is just, you know, provide additional sections, views. There's, like I said again, we love software, we love isometrics, we love information. The more information, the better.
Change colors. When you do a revision mark it up where if you do have to look at it on an iPad, a laptop, something like that. If it's a different color, it draws the attention to it versus just leaving it laying out there where I find it 3 days later after it's already hung. I mean, the more detail you can give in a revision, even if you have to write a narrative and this is what changed and attach it with the field use plans, it greatly helps the guys in the field.
And the other thing is, if there's some field work that has to be done, give us a field work drawing, okay? This is what you're doing to this beam right here, because, you know, you modeled it, you figured it out, this is where this gusset has to be moved to or whatever, and, just gives a field work drawing, so we don't, there's no chance for any misinterpretation. And again, this is just some stair stuff, which, you know, stairs are always, first of all, they're always a hassle because, you know, every meeting I go to, if it's a mid-rise building, by God, we're gonna get the stairs with the building. So we can all have access. When the contractor wants to pour that second floor, he can pour those stairs too. Well, we all know half the time that's not happening. It's not necessarily the detailer's fault. Probably the architect, engineer sat on the drawings too long or whatever. But you gotta remember this, we're building this building without walls in here yet. So we want to see some isometric views and give us some grid lines, something to work off of.
Plus, it helps get your idea of your piece marks, where they go, and not only us, but the general contractor seeing how this stair goes up, and if there's gonna be a conflict, if there's gonna be a knocking issue or something like that. You're detailing it for us to put it up, but a lot of the times you're detailing it for contractors that, for lack of a better term, just came fresh out of college, and they know what they're supposed to do to write a change order, but they don't know how the stair goes up or what to do for that stair, or how it's supposed to look. More of a stair. more stairs. The better information you can give on stairs, handrails, it's not a huge issue, but it does come up a lot, where handrail, wall rail connections go, just like this. This is our detail that kills me. It shows where it goes, but it doesn't give a dimension to it. If you can provide that dimension, it better ensures that I have the backing in the wall when I go to put that rail up, not me sticking a bolt in there and hitting drywall that's never gonna hold anything up. So the more information you can give us on stairs, rails, and connections, the greater the job will be, and everybody will make a lot more money. This is my reference to that. We did this stair. There was a company out of Canada, I wanna say, built this stair. The fabricator had to build it, put it in the price, everything was great. This stair right here scared the snot out of us. I mean, just, the way the glass rails go around it and everything else, this is a children's hospital. And it went up in 3 days. We put a rolled stair from start to finish up in 3 days. I mean, GC was even worried it was gonna take weeks to get this stair up. The better the detailing, the better the fabrication, the quicker it goes up, the more money everybody makes. Everybody's happy.
So, that's pretty much what we got. I would like to say in conclusion, you know, I said it earlier, we are the specialty contractor. I like personally the fact that fabricators don't do erection anymore, you know, and I like it that detailers, there's a lot of detailing firms out there, and you guys are specialty contractors, you know, you're smarter than AE, and you should be smarter than the fabricator project manager, and you're probably smarter than the pole erector too, okay? But if we can work together and communicate, you know, we can all, the idea is to have a nice, safe job, OSHA compliant, industry standards, good to go. And it all boils down to, I don't know how, you know, every time we have a team deem in-house meeting, we always talk about what's our biggest weakness, and the first, it's always communication, right? So the more you communicate, the better off everybody's gonna be. And we know you detailers do not like to hear about erector back charges, right? That's the bad word. Well, we don't like to do them either, right? Just to let you know. I mean, there's folks out there that seem to think that erectors just retire on extra work orders or back charges, and it's not true. Every erector I have talked to in my career, the jobs they want to talk about were the ones that we got the product when we needed it, it was sequenced the right way, it fit, everything was good, didn't even have a change order, but guess what? Because all that stuff came together, we were able to do it in our allocated man hours, so therefore we made some money. That's all we all want, right? You don't want to detail something twice? I don't want to put it up twice. No. Yeah, let's do it. We'd like to give a little nod. Like I said earlier, if you're not familiar with this book, I would hope, and if there's NISD members in there, you're certainly familiar with it. But that is available through the NISD and the Steel Erectors Association of America. It costs $80. And some of it, it looks like this. And it was put together by some really smart detailers and a couple of dumb erectors a long time ago. And there's actually a revision coming out, I want to say probably about June, and I think they're doing a little more seismic stuff to it to help you with seismic connections. But it's a really, really handy little tool, and there's nothing in there that's gonna, I can promise you, no erector's gonna call you up and go, what were you thinking? Right?
Don't promise that.
Well, I won't anyway. That's all I got.
I noticed on your detail for the seat angle connections, when you have double bolted connections, do you prefer, and maybe it's an ultra requirement, to have those shop attached, or do you field attach them?
Well, we like them all shop attached.
Well, in the case where you have 2 levels of steel, can you erect that beam on the first floor if you've got seat angles on each side on?
Yeah, because we can break it over and clear.
Okay. But then on another side of that, bolting it to the beam that's being supported, is that a requirement?
No, It is not.
It seems like I've seen that quite often.
Yeah,
where
that is a major misinterpretation of the rule. Now, it's a good practice, don't get me wrong, you never hear anybody complain about it, but the OSHA double connection deal is about columns, because if you think about it, you're trying to space your columns, right? So if I have a box spaced